My name is Alex Galt. I'm a math teacher at Edina High School. This is lesson 1.6. It's about evaluating composite functions, but it's also about finding the composite function of two different functions. So you're going to be finding an equation for a composite function, and you're also going to be evaluating composite functions not just using equations, but also using tables and graphs. All right, so if you're trying to find a function for a composite function, then what you want to do is actually put the function into the other function. So I'm trying to find out what f is if f follows g of x, which means I do g of x first, but then I put it in f of x. There's not really anything to do for g of x, because g of x is just 3x plus 7. So what I do is I take the f function, and the way I think of it is I'm making a shell. So the f function is 2 times something minus 9. So I'm doing 2 times something minus 9, and the something is g of x. Okay, so then it's really 2 times, well, g of x is 3x plus 7, so it's 2 times 3x plus 7 minus 9. And now it's an algebra problem. I'm going to distribute. So I have 6x plus 14 minus 9. And then if I simplify, I have 6x, which is not a like term, plus 14 minus 9 plus 5. So my composite function is f of g of x is equal to 6x plus 5, and that's my new function. So I'm going to encourage you to pause the video and then try to compose these functions. Remember that g is going to be your shell, and f of x would be inside of that. And for the second one, h will be the shell, and f of x will be inside of that. And for the third one, f will be your shell, and h of x will be inside of that. After you pause the video, come back and see how I do them, just to make sure that you're on the right track. All right, so g of x, the shell will be 3 times something plus 7. And then f of x is going to go inside of the shell. F of x is 2x minus 9. So then the next step is I'll distribute and add like terms. So I wind up with 6x minus 27 plus 7, or 6x minus, oops, I wrote 2, but I said 7. So 6x minus 27 plus 7, so 6x minus 20 is going to be my new function. Here h will be the shell, so it'll be 5 times something minus 3, and the something is 2x minus 9, because that's what f of x is. And then I distribute, so I have 10x minus 45 minus 3, and then if I combine these terms, I have 10x minus 48 for my new function. And for the last one, f is the shell, so I have 2 times something minus 9, and h is what I'm putting in the shell, so h is 5x minus 3. So then I distribute, so I have 10x minus 6 minus 9, or 10x minus 15. And so these are my answers to that work after I go through the steps. These are some more that you can try on your own. I am going to do one of them so that I know that you're not too worried about it. Here g is the shell, but g is also what we're putting inside. So it would look like 3 times something plus 7, but the something is going to be 3x plus 7. I'm going to leave the rest of these for you to try, but it's the same process as the other problems on the previous page. And the other thing that's new this section is we can compose functions when we're given them as equations, but we can also compose functions when we're given the function in a table. And so this process is actually kind of fun. I think of it as kind of following the money. So g of -2 is what we would do first because it's inside of the parentheses. So we're going to go to the definition of g, and if we have g of -2, that would be 1. So we're really finding f of 1. And then we go to our f function and we say, oh, when x is equal to 1, f is equal to 1. So our final answer is 1. Okay, remember this notation just means g follows f of -2, so we're going to do f of -2 first. So we're really doing g of 4, and g of 4 is 5, so that's our answer for that problem. And then for number 3, we're finding f of 0 first, so f of 0 is 0, so we're really finding g of 0, which is 1 from the other table. So it's kind of following the money through the tables. And then the last way we can think about composing functions is when our functions are given to us as graphs. I think the graph problems are pretty similar to the table problems. What you want to do for the graph problems is, again, start on the inside. G of -2 means the x-coordinate is -2, and we're going to go to the g graph. When the x-coordinate is -2, it looks like the y-coordinate is -4, so we're really finding f of -4. And then we go to the f graph, and we say, oh, when the x-coordinate on the f graph is -4, the y-coordinate is 3. So for number 2, f of -1 is where we start. F of -1 is going to be 0, because if the x-coordinate is -1, the y-coordinate is 0. So then we want to find g of 0. So g of 0 is also 0. I encourage you to pause the video and try to do 3 and 4 on your own, and then come back and see if you did them right. So when I did 3 and 4, I got 4 and I got 1. I started on the inside. F of -3 is 2, and then I evaluated g at 2, and I got 4. And then for the other one, I evaluated g at 0, I got 0, and then I evaluated f of 0, and the y-coordinate when x is equal to 0 is 1. So what you should be able to do by the end of today is you should be able to write a function for an equation, for 2 equations that are composed together. You should be able to evaluate a composite function when it's given to you in a table, when 2 functions are given to you in a table, and you should be able to compose 2 functions that are given to you as a graph.